Hey, what's up everybody? Mr. Murray here, Mr. Murray's Mathland, and we're doing a basic video today on using the law of sines to solve a triangle as it's put here. And in case you're unfamiliar with what that means, solving the triangle means finding all missing measurements, all missing sides, all missing angles. So when all is said and done, you should have 6 parts basically, 3 angles, 3 sides. Okay, so let's just jump right into this one here. Um, a little bit about the notation here, pretty standard stuff. I'm just going to draw a generic triangle here. And you really can label things, whatever you want, just a sketch to help you visualize. But notice capital A stands for angle A, 113 degrees. So angle A, angle B, angle C are typically what you're dealing with in this kind of a section. And angle A is 113 degrees, clearly not drawn to scale because that would be an obtuse angle. Angle C is 40 degrees as given. And lowercase b here, this helped me catch a careless mistake there, that angle C is 40 degrees. Sorry if any of you were thinking that there. Good eye. C is 40 degrees. I put it in angle B there. But lowercase b, that stands for side B. And side B always represents the side across from angle B. So that would be this side right here. Likewise, if we had used lowercase a, that would be right here, a side across from angle A. So this side right here is 19.3. And this missing side is side A, or segment BC. And segment AB across from angle C is usually called side C, lowercase c, represent that. Okay, so first thing that's nice to identify when you have given information within this section is what kind of a situation are you given in terms of angles and sides. And if you'll notice, I was given an angle, I was given a second angle, and I was given the side in between them. That is an angle side angle situation. And that means you only have one triangle possible. And if you have one of those classic geometry congruence postulates, that means there's only one way to put it together and only one triangle possible. And yes, there are times in this section, we'll see in later videos, where there are more than one triangle that are possible with the given measurements. So this is just a nice little things to think of and review some geometry ideas. So if you have an angle side angle situation here, we should be able to solve this with the law of sines. And to use the law of sines, here is the law of sines, by the way. The sine of A over side A is equal to the sine of B over side B, which is equal to the sine of C all over side C. And I won't bother to prove that in this video, but it really is a nice little proof just using basic geometry and SOHCAHTOA. And always good. I always usually show it in class. Check it out if you're curious. Just Google it, YouTube it. So the big thing here is to use the law of sines. You need to have what we call an angle side pair to get started, meaning you got to have angle A and side A, or angle B and side B, or angle C and side C. And we have these two angles, and we have this one side, but I don't currently have an angle side pair. But what you should know is that from geometry, that the three angles of a triangle always add up to 180. So if you know two of the angles, you should be able to find the third pretty quickly here. Angle B is going to be 180 minus the two angles that we already have added together, 113 plus 40. So that would be 180 minus those two angles, which is 153. And so angle B is going to be 27 degrees. So we got one thing right off the bat here. Now we got all three angles, and now we have an angle side pair to get us going and help us find the missing sides here. So different people, might like to set these things up. By the way, I set it up this way with the angles on top and the sides on bottom. Some people will set these fractions up as the reciprocals, side c over sine of angles. You can put the sine of the angles on the bottom too. That's just taking the reciprocals of all of them. So let's just dive in here, and it shouldn't matter which side we find first here. So I'm just going to go with finding side A. So here's what I know right now. I know that the sine of angle B, which is 27 degrees, divided by side B, which is 19.3, is equal to sine of 113, that's angle A, divided by side A. And I could keep going and set it up with C as well, but I'm going to just focus on solving one of these proportions right now where you know 3 of the 4 things, and I usually try to not touch the calculator until I have isolated the variable. So if you're good with proportions, you could go right to that right now. If you're a little shaky, we'll do a little cross multiplying here, right? And that would be A times sine of 27 is equal to 19.3 times sine of 113. And we're going to solve for A, so I'm going to divide both sides by sine of 27. So A is 19.3 times sine of 113 degrees divided by sine of 27. And now if I want to find an approximation for that, I'm going to go to my calculator. So here we go. So I'll pull this over here. And one thing you'd want to do when you're in these kind of units is make sure you're in degree mode, which we are. However, you test that on your calculator, and you probably should be able to type this in one big step regardless of what kind of calculator you have. Let's see, 19.3 times the sine of 113 divided by sine of 27. Enter, and side A is approximately 39 point, and we didn't specify how to round, so we'll go good 2 places here. A is about 39.13. Okay, so that's that. And now let's go back and find side C. So we got side A, if I was looking back at my original diagram, it's 39.13. And now let's find side C. What's nice is that you can basically use the same setup you did for side A. The only thing that's going to be different is angle C. So I'm just really going back to that angle side pair I had initially, which is angle B and side B. So sine of 27 over 19.3 is equal to the sine of angle C, which is 40 degrees, divided by side C. And now I'm going to isolate for C again. So, now we can maybe go through this a little quicker. That, what you're allowed to do is cross multiply, and then you're going to end up dividing by sine of 27. So you're going to get C is equal to 19.3 times sine of 40 degrees divided by sine of 27. And you see it's the same exact setup that I just did for A, I'm doing for C, except angle C is in place of angle A. And that's also kind of nice with the calculator because you can bring back the last thing you typed, assuming you're confident that it was correct. You could just change angle A to angle C. And you should get this, which is 27 point. Sorry, we got C is approximately 27.33. And so we should be all done here, but this brings up one final thing here. Lots of little geometry properties. When you're in a unit like this, always good to remember your basics. And that's this. It's a great check to take a look at what you have here and remember that in a triangle, the smallest angle should always be across from the smallest side. 27 degrees, 19.3. The medium angle should be across from the medium side, in this case 27.333. And the longest side, 39.13, should be across from the biggest angle. And so if those things are not the case, maybe it's a way you can catch yourself and go back because you probably made a careless little mistake somewhere, or maybe mistyped a digit in a calculator. But just good things to be aware of as we proceed in this unit. Okay, kids, so that's that, a basic example of how to use law of sines to solve a triangle. And if you got any questions, let me know.